In this video, we're going to look at the expectation denoted by capital E of x, and variance denoted by var x. Expectation of x can be defined as the integral of x times probability density function with limits from negative infinity to positive infinity. If x is a continuous random variable with probability density function f of x, then the expected value of any function g of x is written as integral of g of x times probability density function with limit negative infinity to positive infinity. So, for expectation of x square, it can be defined as integral of x square times probability density function with limit negative infinity to positive infinity. For a and b constants, expectation of a is a. Expectation of a times x is a times expectation of x. Expectation of a times x plus b is a times expectation of x plus b. The mean of continuous random variable x is also known as expectation of x. The variance of continuous random variable x is expectation of x square minus the squared from the expectation of x. For a and b constant, variance of constant is 0. The variance of a times x is a square times variance of x. The variance of a times x plus b is a square times variance of x. Let's look at the example 14. The continuous random variable x has the probability density function as follows. Let's recap. The expectation of x is equal to the integral of x times probability density function from negative infinity to positive infinity. The expectation of x square is equal to the integral of x square times probability density function from negative infinity to positive infinity. The variance of x can be defined as the expectation of x square minus the squared from the expectation of x. To solve question in A, the expectation of x is the integral of x times probability density function with limit 0 to 4. Since we have two distinct probability density function, so our expectation of x is as follows. Simplify this integration will give us 22 over 9. To solve questions in B, we know the variance of x is expectation of x square minus the squared from the expectation of x. Since in A we've already find the expectation of x, so we have to find the expectation of x square. The expectation of x square is equal the integral of x square times probability density function with limit 0 to 4. Simplify this, we got 62 over 9. To solve variance, we substitute the value of expectation of x square, which is 62 over 9. We take away the squared of 22 over 9. It will give us 74 over 81. To find the expectation of 3x minus 1, we use the properties of expectation. This will give us the 3 times the expectation of x minus with 1. Substitute the value of expectation of x, which is 22 over 9, into 3 times expectation of x minus with 1. The answer is 19 over 3. To find the variance of 2x plus 5, we use properties of variance which give us 4 times variance of x. Substitute the value of 74 over 81 will give us 296 over 81. The questions in E. We want to find 2 times the expectation of 2x plus 3. By using the properties of expectation of x, we have 2 times the bracket of 2 times expectation of x plus 3. Simplify this will give us 142 over 9. For the last questions, we want to find 5 times the variance of 3x minus 2. Using the properties of variance, we got 45 times variance of x. Substitute the value of 74 over 81 into the functions and we got 370 over 9.